Hello, everyone. Hi. First of all, welcome. Welcome to our Snorkel AI reading group. We're very excited for you to be here. Today, we're presenting Yijia from Stanford NLP with a focus on human-centered AI and human-AI collaboration. She's going to present her recent work on collaborative gym or co-gym. I am personally very excited about this work because this work shifts the question from how agent works for days from a single prompt to like a more realistic and I think more important question: how should agent work with human, while human preference, expertise, and ultimately the human control are still an important part of the system. And her work provides the infra and evaluation tools for studying this topic on various tasks like travel planning, paper writing, and data analysis, and also shows that human AI collaboration actually outperforms single agent development. Yijia will talk about interesting remaining challenges about communication and situational awareness bottlenecks. Let's welcome Yijia.
Yeah. Thank you so much for the introduction. Hi, everyone. Thank you so much for having me today. It's actually my first time to visit Snorkel's office. It's a really nice place, and it's so great to see a full room of people. It's more people than I expected. I'll start with a very quick introduction of myself. My name is Yijia. I'm currently a computer science PhD student working with Professor Di Yang. And last year, I was also fortunate to work as the first intern at Thinking Machines with John and Lillian. And my PhD research focuses on human-agent collaboration. So actually, for the work, collaborative gym, we will share in details today. It was actually envisioned back in 2024. And in the last 2 years, we have been putting out several work in this direction, engaging not only just AI researchers, but also product builders and economists. So today, during this talk, I do want to share not just the paper itself, but also the story behind why we think beyond full automation from the early on and why we believe human-agent collaboration will be a new frontier. So now let's get started. Okay, I think I'll just manually control this. So I think in the last 2 years, the most unprecedented change in our society is probably these AI agents have finally crossed a capability threshold. So here is a plot from METR, which is an AI startup focuses on evaluation. So on the x-axis of this plot, they are checking the model release date. And in the y-axis, they are checking the length of the task that these AI models can do with a high success rate. And what they observe is the length of the task AI can do is almost doubling every 7 months, which feels like a new Moore's law. So to give you a sense about how crazy this is, so compared to maybe 5 or 6 years ago when I just started working on language modeling, it really takes us a lot of efforts to just make these AI models can answer some questions. However, at this point in 2026, we are seeing these models with some agent scaffolding. They are able to actually do AI research on their own with a certain capability. And the direct consequence of this unprecedented change is these AI agents are now leaving the lab environment, but actually enter very concrete human work. And people are trying to use them as part of their actual human work. And this goes beyond just the software engineer. So here's actually a study from Anthropic where they basically analyze what people use Claude Code for. And what they observe is like people, even beyond software engineering, people are using these agents also in domains such as medical or finance, which are highly kind of specialized, but also critical. So it's really great to see these AI agents are able to do many, many things on their own and able to do things longer and longer. However, in practice, we also sometimes see a lot of tension that, well, these AI agents, they go to work for several hours. And then when they report back, it's basically people are saying this AI agents producing a lot of AI slop, or in some content that's very hard for human to audit or verify. So as a result, sometimes for human, they have to even spend a longer time to verify or to clean up the AI's outcome. Or sometimes for a lot of general public who don't have a lot of information about AI, they will choose to kind of just do the things on their own instead of really leveraging the agents. So here is actually a concrete example I found quite hilarious when the OpenAI, they released a new version of Operator. So for context, Operator is a browser use agent, which means the agent, they can take actions such as click or type, just similar to how human beings are able to manipulate the browser. So when they just released the new version, on Twitter, there was a user saying, well, I'm just trying to use Operator to help me do some grocery shopping. However, instead of asking me what I actually want or where I actually located, the operator agent just go online and try to search for milk in a grocery in a random city. So besides a lot of friction like this in the individual level, in the society level, we are also seeing sometimes these autonomous agents causing the deprivation of the human agency. Like here is actually a quote I saw from Reddit. People are saying, well, we developed this AI to do some boring job and let humans to be creative. But the reality is like now, actually the opposite is happening and people are reviewing what this AI are produced and we actually didn't found we have a better life. So motivated by this, even from an early on, I started my PhD trying to work on human-agent collaboration with a goal to really build these agents to be better collaborate with human and ensure human agency. And along the way, there are definitely a lot of skeptical views, and this is the one actually I encountered the most. So people normally would ask me, well, do you think your research will just be washed away? Like suppose people release a larger models trained on larger data, do you think like the problem will be solved? I don't know whether this will be solved by GPT-6, but at least at this moment with GPT 5.5, I think a lot of problems we just described, they still happen. And at the same time, we are also seeing, well, even though for domains such as software engineer or math, these models are doing a good job, but in terms of how to make these models actually useful to collaborate with humans, especially for those general public who are outside of this AI bubble, is still an unsolving problem. And again, one thing I do want to call out here is for a lot of research we are doing, besides doing experiments in the simulated setup, we are also a strong believer of really testing out with real humans. There are some people thinking is like, well, if you do human-involved study or like a human-in-the-loop study, a lot of time they will involve a lot of fuzziness. And the thing we think is this kind of fuzziness, they are not the bug. It's not like we human, since we are fuzzy, is some sort of buggy. It's actually a new frontier. We really need a new algorithm or new methodology to figuring out how to design these AI models to be able to functioning in this fuzzy environment and to work with the human. So motivated by all this, for the work I want to share today for the collaborative gym, it's actually our first large piece of work where we work in this direction, which provides a framework for enabling and evaluating human-agent collaboration in this dual control and non-turn-taking environment, which goes beyond the normal chatbot interaction. So before I introduce what we actually did with our framework, I do want to do a very quick recap of what's the status quo of today's fully autonomous agents. So normally when people build agent today, we would assume the agent is actually working in a certain environment. And in every step, what the agent needs to do is they will take an observation of the environment. And based on the observation, they will decide the next action. This is basically a very clean RL situation where we see a lot of progress from just optimizing these agents to keep doing longer and longer in the environment. And of course, this process can keep going until the agent decides, well, it's a time to finish this task. So this is basically what we currently have when we develop the fully autonomous agents. However, things will get more interested, suppose you have a human component here. So first, as a human, besides just trying to use the agent to interact with the environment, the human can also take action and observe the environment at any time. So think about now, even you are using coding agent, right? Suppose the coding agent is writing some files. You can, of course, choose to let the agent to modify the file again, but you can also go to review the file or do edits by yourself. So this will pose some challenges to the agent because even before the agent taking any action, the environment can change. Suppose human is actively doing something in the environment. Besides this, there is another relationship between the human agent, is that the human agent, they will also have this bidirectional communication. So the communication can be initiated by the human, just like when you are using some coding agent, you can send some messages even during the task section. But at the same time, the agent can also proactively send a message to the human. So you can think about, like, suppose the agent is needing additional information, then ideally, the agent should message human even before human is sending any question. So given this is the human-agent collaboration scenario we want to tackle, as you can see, compared to the fully autonomous setup, there's more components. And the challenge would be how we define an environment API that is easy for agents to be developed to suit this kind of situation. So the first thing we want to tackle is what are the action space for the agent, right? So this actually is a very important part for this problem because normally when we think about the coordination between the human agent team, we will try to use methods such as, we will applying some turn-taking strategy, which means in some conversation, always the model is responding to the human response. Or another approach is people are developing some agentic workflow where each step of the agent is predefined. However, suppose we give the agent all the freedom, how they should be coordinated with human, right? So in this framework, we introduce two collaboration acts that go on top of the task-specific action space. So basically, this is inspired by how human actually team, right? The human team normally, the way you team up with your teammate is usually through active communication and also intelligent deferral. So intelligent deferral here means, suppose there are some parts you are unable to do. It could either be out of your capability or out of your scope. You would be able to defer it to another party of the team. So here, we actually introduce these two additional collaboration acts that function on top of task-specific action space. So the task-specific action space here, this is really depending on the actual environment you are deploying the agents in. For example, suppose your agent is working in the browser environment, then the task-specific actions will just be click or type. Or if your agent is working in coding environment, then those task-specific action would be some terminal action or like some bash command. However, these collaborative actions, they are shared across different tasks, and this is provided by the collaborative gene framework. So with this additional collaboration acts, even though it looks very simple, but it really unlocks a different way for the human to work with the agent. So here is actually an illustration where we represent each worker, either human or agent, as a separate bar here. So suppose in a session, the human starts the session by sending a message to the agent. Normally, you can imagine, suppose it's in fully autonomous setup, then what the human will do is just maybe they go to wait the agent to do everything, and maybe in the middle, the human is just watching some Twitter or do whatever and cannot interfere with what the agent is doing. However, because our framework supports this dual control between the human and agent, so during the process, both the human and agent can work on the task environment. And suppose agents think, at this point, it's a good chance for me to do something or respond to the human's additional message, they can use the collaboration act to respond back. And even before the human is sending additional message, given the agent have the autonomy to decide what to do next, it can choose to keep working on the task actions to continue the work and even send message to human when the human, even before the human is asking anything. And suppose it realizes, well, to do the next step, I really need the human to answer back. Otherwise, I cannot do. then instead of going into some endless loop and doing some random stuff, the agent can also choose to defer, to skip the later action, to wait for the human to do the next step. So right now, as I just illustrate, even just with this additional wrapper of the collaboration acts, this human agent team will have way more flexibility compared to autonomous agents. However, from an agent developer perspective, there is still a main problem here. It's how can I know, like how can my agent know when to make the next action, right? Because normally in the fully autonomous setup, this is pretty simple. Like agent is just, I take one action and then I take another one. But right now, given the human is actively doing a lot of work in the environment, then agent is still ultimately just a computer program. It needs to be queried at certain times. So how can I know when I need to take the next step? So this goes to a second major component of the collaborative gym framework, where we actually implement a notification system to make sure the agent can be notified at the correct time. So think about this is actually drawing inspiration about how people develop those real-time kind of web framework. So normally for a lot of web developer framework, each components, they are actually all running an event loop. And basically, there will be certain other components in the framework that will emit the event. So from each component's perspective, what they need to do is just they need to keep monitoring the events, and suppose there is a new event come, they will act correspondingly. So similarly, we adopt this idea here. So we would assume from an agent developer perspective, their agent is just need to sit on the event loop and handle an emitted event. And the event will be handled by the notification system in our collaborative gym framework, which basically functions on 4 situations. The first situation is, suppose there are shared components in the environment. So for example, it's like the text editor or like the code base. Suppose there are shared component changing the environment, the collaborative gym framework will make sure the agent get notified. Or like suppose there is a private observation. So here private mean like, because it's a teamwork setup, so there will be different access control, right? Like for the human agent, they will be able to see different things, suppose you configure it to be. So suppose there are private observation updates, then the corresponding party will also be notified. And the rest of the event type, they are relevant to the collaboration acts I just described. So suppose there is a new message come, the recipient will also be notified. So the agent will know, oh, at this point, I need to deal with the new message sent by the human. And the last event type is actually interesting because when we are doing the initial experiments using our framework, we found one failure case in human-agent collaboration is actually like this livelock. People may be familiar in like operating system. So because it's a teamwork setup and each member could choose to defer different parts, suppose they see a fit. So there can be a situation where both the human and the agent are waiting for each other. It's basically the team has no progress just because each party is waiting. So to ensure this is not really blocking the human-agent collaboration, in our collaborative gym framework, we will be able to indicate the agent where, oh, the team has no progress for a certain period of time to just make sure the team will have enough progress along the way. So when we have this framework, as I mentioned before, the API design is mainly with the hope that we pose as less restriction on the agent as possible, right? Because if you look at the diagram, what the agent needs to do is basically every time when there is an event arrive, they can just use any way to decide what's the next action. This actually resonates with a lot of foundings in the industry these days, where with very strong model, you actually don't need very complicated agent scaffolding. Normally, if you go to look at those open source codes such as Codex or Gemini CLI, you will find like their agents is also just functioning on a very large loop where the prompt can be very large, but they basically just a large system prompt and does not have very complicated components. So during our experiments, following this essence, we are basically just using the React agent. When a new notification or a new event come, the agent will access its own memory and can decide the next action. However, to just validate how large this collaboration would have effect on the human agent team, we also test another agent, which basically we use an additional language model core to just decide at this point, should I go to communicate with a human, or should I go to take a task action, or should I just defer a certain part to the human? So in this agent variation, we design this in our experiments is mainly to test whether this planning is specifically important for human agent collaboration. And later I will just share the results we found. For the experiments, in a very high level, the most important questions we are curious about is whether this human agent collaboration would be helpful. Would it actually perform better than fully autonomous agents? So to answer these questions, when we conduct the experiments, the collaborative gym framework, we support 3 representative tasks. One is travel planning. Basically, the human is trying to complete a travel plan, which needs to comply with certain constraints. And also the literature survey is trying to really combine with search tools. So for this literature survey task, the agent will also have access to external database or other search tool. And the third task we experiment with is tabular analysis. So in this setup, the agent will also have the Python executor where they can write some code to do the task. So basically, these 3 tasks, they represent different scenarios where today people use a lot for these agentic systems. And more excitingly is for this framework, we already provide a harness for people to do experiments in both the simulated and real setup. Because what we observe is while the field is doing a lot of simulated experiments, sometimes it's still very challenging for people to even set up experiments to run with real human. So that's why in our open source package, we also provide the support, suppose people want to test their agents out with the real user. What we found is in the simulated experiments with different model backbones, we do see the very significant improvement compared to fully autonomous agents when we put these best performed agents to work with the human. So this actually, at that time, we also tasked with an open source models, which is Llama at that point, because in a lot of scenarios, people may just want to use smaller and cheaper models. So we are curious to see whether we can still see the benefits, suppose we are using a cheaper model. And the answer is actually yes. And more excitingly, when we look at how real user perform, so in this setup, we are comparing our collaborative agents with autonomous agents with real human. So basically, we go to recruit this human on a platform called Upwork. So these people will be paired with the agent to do the task that we assign to them. And what we found is these collaborative agents are also preferred by the real users. And when we look at why people think this human-agent collaboration is better, here's a quote actually I found really well said, and it really matches a lot of motivation even before we start this project, right? We are thinking about how we can preserve human agency and also ensure better outcome. So people actually found not only can can this human-agent collaboration improve the task performance, but also it leads to more natural and flexible interaction. People found it's better than, they just let the agent do everything and then wait and then come back and be unsatisfied and continue the loop again and again. And finally, when we analyze the trajectories we got at that time, we also identify a lot of limitations in both the underlying models and also the agent scaffolding. Most strikingly, the 2 major problems we identified at that time is one is the communication. So sometimes the agent will hallucinate some updates to the human, so which makes people very confusing. I actually have some example if later people are curious, but there is a fun example that the agent is saying, I have already helped you organize all the material, but when human go to check, it actually didn't. So this kind of communication error will really hurt the human-agent collaboration, especially if the human does not have very high literacy about these AI systems. And in terms of the situational awareness, this refers to whether agent can decide when it should do the task or when it should wait for human to continue. And we also found even with models such as Claude or GPT, it's still very hard for them to decide in the teamwork setup what's the right time to take actions. This is probably because in today's training pipeline, we mainly just run this IL loop to make the agent to execute the task, and their objective is the task completion. However, in the human-agent collaboration, sometimes the optimal policy for the agent is actually to let the human to do certain part. And also, when we compare the real trajectories we collect and the simulated trajectories, we actually found there is a high correlation with the error type. So that's why moving forward, in a lot of studies we are currently doing, we are using the simulated users to train the models. However, later test them out with the real users. So this is actually a very quick summary of what we did back then in the collaborative gym paper. And what I actually want to share at the very end of this short presentation is what this work inspires us and what excites us for the next step. So the first thing I do find very interesting is more and more people in the field have realized that this collaboration capability is actually a new frontier for today's models. Even anecdotally, I can share for this CoGym paper, it is now presented in iClear this year. But actually, in last year, we submit to Europe's and ICML, it got rejected. And both because they're in the reviewer batch, there's one person always asking, oh, why we want human in the loop? Why would you need agent to collaborate with human? And this person, I think it's other score are above 7, and this person always give a 3. So this makes our paper just hard to be accepted. But very funny is for follow-up work in this CoGym line, where I will share a little bit later, we submit to column, and it just gets really, really high score. And we didn't meet people saying, oh, well, why do you need human anymore? And even from the Frontier Lab, when I communicate with those people, I also see people start to more and more focus on the collaboration capability rather than just training the model to do code or to do solve math. So one concrete example is actually these interaction models released by Thinking Machines. So basically, they optimize this model exactly for the multi-turn interaction. And one large part they try to solve is make this model know when they should interrupt or when they should just let the human to do the talk, and also how to make this multi-turn interaction smooth. And also recently, when I look at the recent technical report from Anthropic, they actually point out, even for their strongest models, it's still very hard to make multi-agent collaboration work. So here is a little bit different from the human-agent collaboration setup we are studying. They are studying whether we can use multi-agent to do larger projects. And what they found is that even though this can speed up the process a little bit due to parallel execution, it's still very hard to achieve higher task performance because of this coordination issue, which is very similar to what we observe in the human-agent collaboration setup. Besides this, moving forward, one thing I do think the current collaborative gym framework didn't provide is the final task performance you see is actually a combination of the human work and the agent work, right? So even for the plots I share, even we see the collaborative agent is achieving better, but there is still a possibility that the achievement is coming from the human, which is doing a lot of work. So that's why in our recent work, we try to use a Bayesian framework to disentangle the contribution from both the humans and the agents. And very excitingly, I do hope in the follow-up work, we can do more progress on upskilling human worker, because what we notice is that the performance difference between different agents, such as Codex or Cloud Code, their difference is way smaller than the difference of different human workers who we try to pair with them up with the agents to do certain tasks. So if you check out our current collaborative gym framework, it actually have this update, and hopefully we can present the work in column, which will also happen in SF later this year. And we are also very grateful to be supported by the Law Institute to support us to focus more on improving the human side, because I think for my PhD research, since my goal is to advance human-agent collaboration, but it's a bit sad that in the last 2 years, most of my work is still focusing on how to build better agents, how to train better models to be collaborative. However, I do think at least the same amount of effort should be put to upskill humans to make them work with the agents more effectively. So for more information, if you are interested, we actually put all of them on our platform. We are also hosting an interactive platform for people to try it out. And finally, to end this talk, I also want to share a podcast I'm actually running with a friend at MIT and another friend at Stanford. So over the last few years, I do see there are more and more people start to work on human-centered AI. So we actually start this Augmented Mind podcast this year to share the work that is out of my direct team. So far, we have been covering work around like user modeling and also building AI systems for imperfect human and also getting some infra people to talk about how to support these interaction models or how to develop infra in a human-centered way. And suppose you are interested, feel free to check it out. Okay, thank you so much for your attention, and I'm very happy to take any questions.
Yeah, thank you, Yijia, for the amazing presentation. Please stick to future works, amazing works. Yeah, also, I feel like these days sometimes some reviewers makes me question, why do we have human reviewers in loop? Yeah, let's get you a microphone.
Oh, sounds good.
You can give me that one. Take it. Questions? Yeah.
Oh, I just closed it. Maybe you should.
Yeah, let's we actually have this cute box microphone that's that you guys can throw around. And
oh, this is so cute.
yeah.
That's kind of cool. Right, I've got a question about current models. You teed it up right at the beginning. In your evaluations, have you looked at the impact of what happens to the difference in performance when using a more advanced model? Does the difference get more extreme, less extreme? And also curious how this relates to the ability to interact in Claude code. It seems like you can, add a prompt even as it's working.
Yeah, so this is a very good question. So actually in our evaluation, so basically the CodeGym framework was first developed to just help us evaluate different models, right? And of course we see larger model or like those proprietary models such as OpenAI's GPT or Claude, they perform better than this Llama model. However, we also see the trend of this effective human-agent collaboration can outperform fully autonomous agents. This holds true even with like Llama model at that time. So this is the finding we have. And suppose you are interested in this topic, there is actually a paper from MIT, which is using our platform to look at the collaborative scaling. So I think their typo is probably like collaborative scaling or completion is not just the collaboration. You can search like MIT work. And what they found is different models, they scale this collaborative effect in a different way. For models such as Claude model, they actually can keep user engaged. So with more tokens or with more turns, the team will have a better outcome. But for some model, they didn't observe this collaborative effect when they scale up with more turns or more compute.
So I had two questions. In real world complex workflows, there would be people with multiple skills, right? So for example, someone is doing product, engineering, legal, finance, so on. And within a single, expert skill set, there would be multiple levels of expertise, beginner, intermediate, expert. So for solving a real world workflow, I would imagine instead of just one human, there would probably be different skills, different levels, multiple humans. So how would this framework take that into account? So that's first question. Second question is, for improving this, performance on this framework, would the model training be done in a similar way, or would you have to make changes for making it better on this framework?
Yeah, so basically you have two questions. I'll try to answer them separately. So the first question is saying how this framework can handle multi-party collaboration beyond one human and one agent. So basically when we develop this framework, there are two major parts as I just explained. The first part is different party, they will have the collaboration acts, which is on top of the task environment. So this will shared when you enlarge the number of agents you have in this framework. So even when you have more than one agent, this will still apply. And similarly, for the another component, which is the notification protocol, this also apply. Suppose you have more than one agent. So I think this framework could scale. Suppose you have more than one agent in the task. But I think suppose they are more human, this thing will be more interesting because then the human part, they also need to coordinate, right? Basically, the human need also to chat with each other. And this becomes like a human coordination problem, which we actually haven't really tested out. But for a short answer to your first question, is this framework would support one human with multiple agents? And suppose there are multiple humans, I think that is a question beyond like the AI part. It's also a lot of part about the human coordination. And could you remind me, what's your second question?
Training, like, is it some training approach would be different here or same as today?
Yeah. So in terms of the training approach, I can share a little bit about like how people do in the interaction model, which I also contributed last year. So for human in the loop part, it's really hard to really have the human to sit on the GPU to give you the interaction. So a lot of time people do is to have the simulated user, but ultimately you can still use the way to grade the whole rollout. So this would elicit the model to have certain capability, such as being able to know when to ask question or when to defer to the human. So this is something doable even within today's RL framework, but suppose you provide the right task and to have a nice user simulator. However, for the challenge, I think I just show, like even with this multi-agent setup, like in complex task, how to make sure these agents can coordinate with each other or even amplify each other's capability. I think this is still an open question, and we are doing very active work in trying to see how we can come up with better training method beyond just to have a simulated user to pretend they are human.
Hey, this is Bruce from Northeastern University. This is cool work. This is the capability that I want exactly for my cloud code. You know, like every time when I launch my cloud code for long tasks, like when it goes wrong, like I have to wait until the end and then until it crashes, right? So, maybe I missed and you explained, but I do want to know, like, how do you make the agent in your framework be aware of when to ask questions during the task execution? Yeah, can you elaborate?
Yeah, so when I just explained for this work, since it's aimed for serving as an evaluating platform and also for people to build agent for this setup. So we didn't actually spend time to really train the agent to improve the agent. And one thing we do try to just amplify whether this collaboration is important is we use a specific prompt to given the current situation to let the agent to explicitly reasoning, should I communicate with a human or defer to the human or just do the task action at a point. So this is a basic thing we did during this work. And we found by letting the agent to spend more compute to make that decision, this already helped for the human agent collaboration. However, moving forward, I think your question is actually very relevant with the previous question just asked, is how we can really improve the agents in terms of the making the decision. And I do think a lot of new training methods should be developed. But actually relevant to your kind of friction with like using cloud code, I think it's even beyond whether the agent can know when to communicate with you or when to kind of defer a certain part. It's also really relevant to how the human agent interface is. So actually, in a recent work, when we use this code gym to just compare commercial agents, such as like Codex, Cloud Code, and actually Cowork, which is another agentic product from Anthropic. So I think the Cowork and Cloud Code, they share exactly the same agent scaffolding. So underlying agent is the same. And also we choose to use exact same model. However, when we pair them up with humans, we found actually for general public, using Cowork, they will significantly outperform using Cloud Code. And this actually, the difference mainly comes from the human agent interface, because in Cowork, first, you don't need to use terminal, which many, I think, general public are not very familiar with. And also they will show like what's the progress of the current agents. Like they will have like a checklist, like basically which part it has done. So it also helps the human to know or better audit the system. So basically, for your question, I think there will be two parts. One part is definitely we need better method to train the model to improve their situational awareness, like being able to know when to do the task or when to ask human. However, similarly important is how to design better human agent interface to make sure the human can stay in the loop or audit. Human in the loop is not just, oh, you have a human, you just necessarily be in the loop. It actually needs a lot of design to make it happen.
Thanks. I have one more quick question. Like regarding the benchmark, I feel like the methodology is skipped. So was the process automated? Like how do you evaluate the score?
Yeah. So basically I actually didn't go very deep since they only asked me to talk about 20 minutes. So if you check about our paper, so for the 3 environments we built, they all come with their specific grader. So it's a combination of LM and a judge and also some rule-based check. And for the actual experiments, this framework support both the simulated setup, where the user is simulated by a language model, but it also comes with a user interface, so you can just hire people to pair it up with the agent.
Yeah, actually, let's take last 2 questions because Yijia has to go pretty soon.
Okay, hi, my name's Seth. I feel like it's a little bit weird to think of it as human agent rather than just like a collaborator, where the collaborator could be also AI. Did you try simulating the human with another agent? Like as the agent's going through the checklist, could you not have an agent overseer, like managing that agent?
Do you mean is like, have you considered simulating the other agent as a human part? Or can you explain the question?
Okay, so right now you have human agent.
Yes.
Agents taking turns with the human. You could have the human replaced with an agent who believes it's a human control.
Yeah, this is actually what we did in the simulated setup. So basically, the simulated setup is we use a language model to simulate the human. So basically, that setup, you don't need to have an actual human to sit there. And we actually show that when we compare the arrow type we found in the simulated setup and the real setup, they actually have very high correlation. And that's why currently, when people do a lot of model training to consider the human parts, they would use the simulator so that they can do own policy training, which will still have some chance of transferability when you test it out with a real human. So actually what you propose is very true.
Were there certain tasks that you got better performance on with the agent versus the human agent?
So this is actually there is an interesting result I actually didn't share very much, is when we test with simulated humans, sometimes the human agent team cannot deliver the task at the end. Basically, the agent and agent, they will have some coordination issues, such as both of them think the other person need to do it. So ends up within a certain compute limit, they cannot finish the task. However, when we test with the real human, so we actually got over 150 people to join this study. And for all the sessions we collect, all the tasks are finished. So this actually is one major discrepancy between the simulated experiment and the real experiment. Like with a real human, even sometimes the agent isn't behave very well, the human will try to drive the task completion, which won't happen suppose you use an agent to simulate the human.
You need a better agent then, I don't know. Thank you.
Last question.
I guess I have a question about more of the specifics of this, of like when you have an agent simulating a human, like what specific, biases does the agent framework have versus the human agent? Like, is it, say you're planning a trip, is it like, I guess I'm asking, what is the human agent fine-tuning on top of the agent add?
So actually, there has, I think starting from this year, there has been a lot of investigation on the user simulator. I think it's also part of because the field has realized this human agent collaboration is something very important. And because many labs, they are trying to train against a user simulator. So there are actually a lot of very detailed study to just analyze the user simulator's behavior. And one thing people found is compared to real user, normally this simulated user, they will be more willing to cooperate with the agent. So they will be more easy to satisfy compared to the real human. So I think this is the major difference. Suppose you are using the simulator. And when you say like how it compares with training against the real users, I think I haven't really seen head-to-head comparison there, because if you ask about training, then one practical constraint is it's very hard to train against real user own policy. Because I think the recent success is like for Cursor, when they train their tab model, they are doing actually live rollout using their consumers' data. But that is because this tab model is still simple, so you can do kind of pseudo own policy training with real human. But for this agentic task, suppose each session they need to take hour to finish. It's very, very hard to train against real human own policy. So I don't personally know head-to-head comparison in the training setup. But from the evaluation stuff, people have found like user simulator is usually easier to satisfy compared to real human.
All right. Yeah. Thank you, Yijia. Yeah, amazing work again. Let's follow up with her new exciting works through the podcast and her later publications. Yeah. Thank you.